was to, because I did a lot of computer vision in the past and a lot of perception, was to boost the perception algorithms that we had at ATG. So this is an example of, in this case, is a single image object detection. This is a state of the art. And one thing to notice when we build systems that need to run in vehicles is that you have to build a detector that is able to work in all weather conditions, in all times of the day, in all different cities, and is able to generalize well, right? Building a detector for the night, building a detector for rain, building a detector when it's sunny, etc. This is not something that scales, right? And then you end up, switching between these things. Instead, you need technology that actually is able, as I said, to generalize broadly. And one of the things that was very interesting to me is that I thought that night was going to be difficult, but it turns out that day and night there is not so much difference into what you can do with a single camera. So to the naked eye, it's difficult to see, but these cameras empowered by AI can actually see much more than we can. Now, doing self-driving with just detection is problematic, and the reason why it's problematic is that a detector, despite the fact that there is evidence that there is something in front of you, might decide to not place a bounding box because maybe it's under the threshold that you decided. So that's dangerous in the sense that there is going to be maybe an obstacle and you might run through it. So instead, we develop methods that are able to use detection, but at the same time are able to explain all the pieces of evidence such that you can actually drive safely. In the context of images, the equivalent of this is instance and semantic segmentation, right? Where for every pixel you need to say what is the category of interest. In this case, whether it's road, vehicle, sign, etc. And for things that are countable, you basically want to also place a contour distinguishing that this particular car is different than the car next one. Okay? And for driving, it's important that we understand, where are the cars and how many they are, etc. Now, I show you, a few things that are actually image-based, and you see a lot in the literature, particularly in academia, about 2D detectors and things like that. But for the task of driving, detection in 2D, segmentation in 2D is not the thing. Okay, so if you're working on that, that's it's an interesting task, but it's not what you need to solve. What you need to solve really is reasoning in three-dimensional space. Because for motion planning, you need to understand where are the actors with respect to you, where is the road, where are the things that, and how you can drive in this particular scenario. So what I'm showing here is a multi-sensor 3D object detection that runs in a few milliseconds. And I'm showing, so bounding boxes basically represent vehicles, and circles represent, in this case, pedestrians. In this case, for this particular algorithm, we are not reasoning about height, so I'm just showing you a canonical height. But the idea is that you, and I show you the projection in the image space as well as in later space, so that you see, in both cases, how accurate the system is. This is actually just detection; there is no tracking. Right? This is independent per frame. And I show you this just to showcase, how stable these detections are these days. So this is a state of the art. And one thing to notice is that it's important that you actually fuse the sensors, neither early fusion nor late fusion. This is what you typically see in the literature. It's important that none of these two things is optimal, right? Instead, you should learn how to fuse across multiple levels. Okay, and that was actually, a lot of the things that we develop is into what are these fusion operations, such that you can actually do this well. So it's important for us also to keep an eye, so not just to have progress with respect to the, our software stack, but to keep tracking, so how are we doing